All right, are you ready for a little cosmic detective work? Today, we're cracking open a case file on a real stellar mystery. The scene of the crime, an open star cluster called Messier 46. It's a glittering swarm of stars, about 5,250 light-years from us in the constellation Puppis. But hiding in plain sight are a couple of strange objects that just don't seem to fit in. Are they part of the family, or are they cosmic imposters? Let's find out. So take a look at this. This is Messier 46, or M46 for short. It looks pretty peaceful, right? Kind of like a quiet celestial neighborhood. You've got about 500 stars here, all born from the same cosmic cloud, all kind of hanging out together. But, as we're about to see, this seemingly calm family photo has a couple of very unexpected guests crashing the party. So that brings us to the big question. Are the two nebulae we see in the same patch of sky as M46 actually part of the cluster, or are they just photobombing the shot, either way closer or way farther away from us? Our two main suspects are a planetary nebula named NGC 2438 and a really strange-looking character called the Calabash Nebula. The investigation begins now. Okay, first up is our most obvious suspect, the planetary nebula NGC 2438. And hey, quick side note, a planetary nebula has absolutely nothing to do with planets. It's just the beautiful, glowing cloud of gas that a star like our sun puffs off when it's dying. Now, what makes this thing such a prime suspect is its location. I mean, look at it. NGC 2438 seems to be sitting right in the heart of the M46 cluster. Visually, it looks like it belongs there. For a long time, this made astronomers think it was a member, which, by the way, would be a huge deal. We've never definitively found a planetary nebula inside a young cluster like this before. To crack this case, we need a special piece of forensic gear. Let's call it our cosmic speed gun. It measures something called radial velocity, which is just a fancy way of saying how fast something is moving toward us or away from us. See, if the nebula and the cluster are a real family, they should be moving through space together at more or less the same speed. And bam, here is the smoking gun. When astronomers pointed their speed gun at the cluster and then at the nebula, the speeds were completely different. We're talking a difference of 30 kilometers per second. That's over 67,000 miles per hour. They are definitely not traveling together. So the verdict on this one is clear. Case closed on our first suspect. NGC 2438 is just a coincidence, a chance alignment. It's an object that's actually closer to us than M46, and it just happens to be in our line of sight. A classic cosmic photobomb. But with one suspect ruled out, our investigation takes a turn. We now focus on the outskirts of the cluster, where our second, and much weirder, person of interest is lurking. It's a bizarre object called OH231.8 plus 4.2. And it's a protoplanetary nebula, an even earlier, messier stage of a star's final moments. Just look at this thing. This is the Calabash Nebula, and it looks nothing like its quiet neighbors. This thing is pure chaos. We're seeing these incredibly powerful jets of gas and dust blasting out into space at over 1,000,000 kilometers an hour. It's a super brief and violent phase in a star's life, and we are incredibly lucky to be seeing it happen. And as if it wasn't strange enough already, you're gonna love its nickname, the Rotten Egg Nebula. Seriously. Why? Well, because it's full of sulfur-based molecules. So yeah, as beautiful as it is from a distance, you probably wouldn't want to get a whiff of it up close. So, after our first suspect turned out to be a total imposter, you might think this weirdo on the outskirts has absolutely no chance of being a real member. But to be sure, we need a definitive test, something like a cosmic DNA test, to prove its relationship to the cluster once and for all. And that test is called trigonometric parallax. Now, that sounds complicated, but the idea is actually simple. It's basically the same way your brain uses your two eyes to perceive depth and distance. As the Earth orbits the Sun, nearby stars seem to shift their position just a tiny bit against the background of much more distant stars. If we can measure that little shift, we can calculate the star's distance with amazing accuracy. If the nebula and the cluster are at the same distance, well, they're almost certainly related. And the results from some incredible astronomical work absolutely sealed the deal. The parallax measurement for the M46 cluster and the parallax for the Calabash Nebula are a near-perfect match. The data is undeniable. They are both at the exact same distance from us, about 5,250 light-years away.
And there it is. The verdict is in. The one that looked like a perfect fit, right in the middle, was a fake. But the chaotic, stinky, rotten egg nebula way out on the edge? It's a confirmed member of the M46 family. What a fantastic twist.
But hold on, this discovery just opens up a brand new mystery. If the Calabash Nebula is part of the family, why is it acting so weird? Why is it moving so differently from all its siblings? See, the data shows the Calabash Nebula is speeding away from the rest of M46 at over 15 kilometers per second. That's a huge difference. A member of the family shouldn't be running away from home like that. Something must have happened in its past, something that gave it a powerful kick. But what? So astronomers came up with 3 potential scenarios. 1, maybe it's a runaway star, flung out from the cluster's crowded center after a close call with another star. 2, maybe it was in a binary pair, and its partner exploded as a supernova, kicking it out. Or 3, and this one is the most dramatic, maybe it's the aftermath of 2 stars violently smashing together and merging into one. Well, we can probably rule out the first 2 pretty quickly. The nebula is way out on the edge of the cluster, not near the dense core where those kinds of gravitational ejections usually happen. And a supernova? It's so violent, it's really not clear the system we see today could have even survived it. That leaves us with one very compelling possibility. The leading theory is just incredible, a stellar merger. The idea is that this whole system used to have 3 stars. 2 of them got too close, spiraled into each other, and merged in a cataclysmic event. This merger would have been messy and asymmetrical, creating the kick that explains its high speed. And get this type of merger can also cook up the exact kind of unusual, sulfur-rich chemicals that give the rotten egg nebula its famous name. It solves both mysteries at once. This is just a huge finding, giving us a real-life lab to study one of the most chaotic moments in a star's life. So, after all that detective work, what have we learned? We've unmasked an imposter, and we've confirmed the identity of a long-lost and very, very troubled member of the family. What this really proves is that you just can't judge a star cluster by its cover. The universe is way more complex and dynamic than it looks. A simple cosmic coincidence can fool us for decades, while a seemingly quiet family of stars like Messier 46 can be hiding these incredible stories of violence and chaos right under our noses. And that really makes you wonder, doesn't it? As our tools get better and better, allowing us to measure the universe with more precision, how many other cosmic dramas are out there, hidden in plain sight, just waiting for someone to connect the dots and solve the case?